What do you mean by deviation without dispersion? So I'll take two different types of prisms. This is A dash. This will be mu dash. So this will be the crown prism. This will be flint, crown glass flint. The refractive index of the material will be slightly different. Suppose a mu for crown 1.57. For flint, it will be 1.59. Slight difference in the refractive index of the two materials. I'll make them prism of different some small angles. Again, we are discussing small angle prisms. So this is called like a combination. So I want deviation without any dispersion. Means when a light passes through a prism, it will spread. But what I want the white light to pass through the prisms. Let it undergo deviation, but there should not be dispersion. So for that, I'll take the combination of prisms here. So let's go for the ray diagram. I'll decrease the thickness of them. So when a white light is incident, so first the red, then this will be the violet, I'll choose some other color because prism I have to show yellow color light. No? Yeah, fine. Okay, this will be the flint glass prism, chrome glass prism. Okay, there's a flint, refractive index be mu dash, angle of prism let it be A dash. The violet also will undergo deviation. And finally, I'll get back the, if you see these two, there is a deviation. The deviation suffered by the yellow color light is what? So there's a white light. So no question of that one. So what was the incident? Incident white light. Emergent white light. Sir, why you are not showing yellow color light? Of course, yes, you can take the yellow. There'll be yellow also. So this will be red, violet. This will be yellow. Okay, there's a deviation. So there's the incident light. If you look at the incident and emergent light, they're not parallel. So there's the deviation. But the incident light was white light, and the emergent light was the white light here. So therefore there is no dispersion, but there is a deviation. Okay, let's discuss this particular condition. What should be the net angular if there should not be any angular dispersion. Net angular dispersion plus we'll take it. So this should be 0. This should be mu v minus mu r into a. So therefore this a dash is equal to minus of mu v minus mu r a bar some formula I obtained here. So for combination for achromatism, what we call achromatism, so this called like a achromatic combination. Achromatic means I should not get any colors here. Condition for chromatism means there will be color. Achromatism means there should not be any color in the emergent ray, that one. So it has to satisfy this basic idea. For achromatism, so if you don't want any like a spreading of light, splitting up of chromatic light, no, so then it has to satisfy this condition. Okay, let's calculate the expression for deviation. What about the dispersive powers? How they'll be related to this? Okay, now I'll bring one more condition. How dispersive powers and deviations are related. Huh? So from this equation, we know mu v minus mu r. Let me adjust mu y minus 1 mu y dash so this mu y minus 1 this will be deviation for the omega delta dash omega dash. Sir, how you are writing directly? Mu y minus 1 into a I'll write one more step. I'll write one more step. Can you write this a here? Can you write this a here? So what is this quantity? What about this quantity? This will be angular dispersion by mean deviation will become dispersive force. And this is the mean deviation for the crown prism, mean deviation for the flint prism. So therefore this will become delta mean deviation. The deviations is called as mean deviation omega delta dash omega dash. So like this now we will get a some basic equation dispersive power omega by omega dash equal to delta dash by delta. If omega dash greater than omega, then A should be greater than A dash. depending upon how you want conditions, no, you can bring it here. Okay, after this we'll go for the net deviation. So the net deviation is given by the net deviation delta net is equal to plus mu dash minus 1 into a dash. Later on I'll bring that some image. Now you see this. Further we'll explore this equation. Mu minus 1. So shall we adjust mu minus 1a? Let me take common. Mu minus 1a will be common 1 plus then I'll adjust one more mu v minus, okay, this will be mu minus 1a a dash, we have derived expression for a dash, no? Yeah, substituting this equation there, 1 plus mu dash minus 1 by mu minus 1 a dash by a, I can also write it as there's the equation. A dash by A, I'm replacing from here. A dash by A, what we can write mu V minus mu R by mu V dash minus mu R dash. Now we will readjust these things. Huh? 1 minus mu V minus mu R by mu minus 1 into what is mu V minus mu R? So this should be the dispersive power. And this quantity will be deviation. The net deviation given by this particular formula. So here we have replaced here. These two quantities are replaced by omega. This quantity, different colors I have to use. This quantity is replaced by omega. This quantity is replaced by omega dash. Okay, fine. So when deviation without dispersion, okay, there's a one basic mathematical formula is what we have obtained. Achromatic combination, this is what we obtained here. Okay, practically, let me show some image which I took from other sources. Hope everyone is able to see the complete description. Yeah, this is our basic discussion. So now, if a white light is passing through it, it will spread in the first prism. Okay, again the spectrum will undergo deviation. Then again here what means the second prism will recombine light. So recombine white light is what the emergent light again will be white light only. I don't get any spectrum. White light is incident, again I'll get back the white light. So therefore, we don't have any dispersion. But if you look at these two, there is a deviation. What is that net deviation? We have this one. So if you extend this line, so these two, the incident and we combine white light, they'll not be parallel. And what is that deviation suffered given by this particular formula? This is a condition for achromatism. For this to happen, the mu of a material for the violet and red and the angle of prism should be related in this way. Okay, so I think do remember this will be very, very important equation. If you know formula, because in exam you can't derive, you are supposed to remember this. Net deviation, already I wrote it here. Different books, they are given different method. Okay, we can just the basic formulas are very important. How the deviation without dispersion, how the dispersive powers and the deviations are related. There's a formula. Net deviation, there's a formula. Condition for achromatism, there's a formula. I think the three formulas. Please try to remember and just underline.